So question number 1 reads, explain the following concepts: break even, the degree of operating leverage, elasticity of production, production function, least cost input criterion, economies of scale, and margin of value product. This is about 20 marks, so you cannot afford to miss out any of the questions. With some formulas, so quickly, I'll not take much of the time to explain this. So to explain the break-even analysis, so break-even analysis is simply a point at which our total revenue is equal to our total costs, or a point at which our profit is zero. So this point is important because it helps us identify the minimum sales volume to avoid what? Losses. So it's given by BEP is equal to fixed costs divided by selling price minus variable cost. So you get your 4 marks for that. The next is operating leverage, degree of operating leverage. What is the degree of operating leverage, or DOL? DOL is simply a measure of risk. It measures the change in sales that affects our operating income. It is given by the following formula. DOL is given by contribution margin over operating income. So it measures how the change in sales affects the operating income. It indicates the sensitivity of operating profit to changes in the sales volume. So that is what we call DOM. Okay. So the next one, we're asked to explain what you can try these ones. What is elasticity of production? How do you understand elasticity of production? Elasticity of production is simply the responsiveness of input to changes. It's the responsiveness of output with changes to input. That is elasticity. Whenever we're dealing with elasticity, we're basically looking at the sensitivity. So how output changes with input. So when we're looking at productivity, looking at factors like labor and capital. So when dealing with elasticity of production, basically we're looking at what? The sensitivity. It tells us how much output, which is the production, changes when we change the amount of input, resources like labor and capital. So in this case, if our output increases more than the input, or if it's greater than 1, we say that is what? Elastic, which is good. If it's less than 1, it is inelastic. Then we have what we call the production function. It shows the relationship between inputs like labor and capital and output in the general form. So this is a production function. Q is equal to the function in terms of labor and capital. So the production function shows the relationship, what you input like labor and machines, and what you get as output. So that is a formula where L stands for the labor, and the reward for labor is wages, and K stands for capital, and the reward for capital is rent, and Q is for total output. All right. So we also have what we call the least cost input criterion. It's a principle that suggests that firm should combine input in such a way that the last dollar spent or the last quarter spent on each input will yield the same marginal product per dollar. Okay, so the least cost input criterion is the idea that a business should use its resources in a way that will give it the most output value for its money spent. So each quarter spent on inputs like labor and capital should give you the same benefit. That's what we call our least cost input. Then we have what we call economies of scale. Economies of scale. Have you ever heard that term, economies of scale? So what is economies of scale? And dealing with economies of scale, we're basically looking at what? A company that grows and produces more at lower average costs. This happens when we can use resources more efficiently when operating at a larger scale. So that is called economies of scale. It is actually producing goods and services at a lower cost. So Zambia Sugar has economies of scale because it's able to produce sugar at lower cost than Mansa Sugar. That's why the cost of Zambia Sugar may be lower. Then we also have what is called the marginal value product. It shows the extra money that a company earns when it uses one more unit of input, like hiring one more worker. That is called the marginal value product. It is found by multiplying the marginal physical product times the price of the output. So that is how we calculate that. Okay, so that is on a light note. These definitions you may read on your own. Then we go to question number 2. So question number 1, we are done. Question number 2, we have been given the price function and we are asked to maximize our profit and to find the actual maximum profit. Okay, so this is under optimization. So optimization comes in 4 ways. There's optimization with what? Production. There's optimization with what? Profit. And optimization with costs. So we want to look at optimization in the context of profit. So I'll come up with a small formula. Let us suppose we have a price given by 100, 1000 minus 5Q. Okay. 100 minus 5Q. So this is the price function. So when they ask you to maximize revenue, so total revenue is maximized when you do what? When you equate the marginal revenue to 0. When the marginal revenue is equal to 0. So you find the price and quantity that will maximize your total revenue. So I've made this question so that you have an understanding. So if this is your price, to make it a marginal revenue, you simply multiply a 2 to the gradient. So this number there, just multiply by a 2 to become marginal revenue. We're going to have 100 minus what? 10Q. If here there was a 4, just multiply 4 times 2 would have been 8 there. That is a shortcut for making price become marginal revenue. Then you equate to 0. 0 is equal to 100 minus what? 10Q. So when the Q comes this side, 10Q is equal to 100. So how do we solve for Q? We divide both sides by what? Divide both sides by 10. So here we're going to have our Q is equal to what? 10. So Q stands for the quantity. So 10 units here will maximize what? Our total revenue. But what is the price that will maximize the total revenue? You substitute this in our quantity there. Usually, if it's total revenue, it is half of that. So if there's 100 there, the price will be 50. I'm just giving a preamble. So here, our price would be what? 100 minus 5Q. Where this Q, put a what? 100. So 100 times 5 is 50. Here it was 10, sorry. It was 10. So 10 to 100 is 10. So here we're putting a 10 there. So when we calculate that, it will be 100 minus 50, which is equal to 50. So our question now is answered. How many units will maximize total revenue? 10 units. What is the actual price that will maximize our total revenue? Price is 50 kwacha. And what is our actual total revenue? Our actual total revenue, we know our total revenue is equal to price times quantity. So what is our price? Our price is 50. What is our quantity? Our quantity is 10. So the actual total revenue in this case becomes what? 500. Are we together? Right. We are optimizing total revenue. Let's try another question before we answer profit maximization. Suppose you have your price as the same one here, 30,000.
Calling is just before you go
Mm-hmm.
further. Uh, uh, I'm seeing the function which the one you posted that says that P equals hundreds minus 5Q,
Mm-hmm.
and where you put MR equals hundreds minus 10Q. Was there a square on the P for it to be 10?
No, I mentioned to say the shortcut for converting price into marginal revenue, just multiply it two here. It becomes that. The long cut is simply you find the total revenue first. Our total revenue is equal to what? Price times quantity. So what is our price?
Mhm.
Our price is what? 100 minus what? 5Q. Put 5Q there. Then the Q we are never given, you impute it. So we're going to have a Q there. So 100 times Q is 100Q. 5 uh, Q times Q, it's 5Q squared. So this is our total revenue. So you now need to differentiate to get
Okay,
our marginal
I think I
revenue.
understand now.
So the TR over the Q becomes our marginal revenue. So always economists or mathematicians have known that most people are lazy. 100Q becomes 100. 5Q squared becomes 10Q. So now they've just made it easy for you to just remember that if you just have a price function there, just multiply a 2 there so that you don't go through this if you can't remember. So in this case, if we have 30,000, okay, minus 0.1Q, what becomes our marginal revenue using the shortcut? Marginal revenue there would be what? 30,000 minus what? 0.2Q. You're just multiplying this by 2 altogether. Then you equate to 0. 0 is here, 30,000 minus 0.2Q. So what happens when this one goes this other side? We have 0.2Q is equal to 30,000. Then you divide both sides by 0.2. Our Q therefore will be what? 150,000. So that is the number of output that will maximize your revenue, your total revenue. Then what is the price that will maximize your revenue? You are going to put it in here. But I've given you another hint to say usually half of this figure there. So if there's 30,000 here, your price will be what? 15,000 there. I'm just trying to relax your mind by not going the complicated way. Altogether. So this will give you about 10 marks just solving this. Then what is your actual total revenue? Total revenue is price times quantity. So our price times the quantity. You put the figures you got here. Price is 50,000 and the quantity is 150,000. Then you get your value there. Is that clear? Can you miss the 10 marks for this surely? Esther Mkombwe, admin, I'd rather you enter with your name because I need to address you by your names. Are we together?
Yes, sir. We're following.
All right. So this is on revenue maximization. So before I go to profit maximization, I wanted you to try something on your own together. So suppose we have our P is equal to 5,000 minus 2.5Q. What is our total revenue? If this is our price, what is our total revenue? What is our marginal revenue? Our marginal revenue is what? 5,000 minus, you just multiply a 2 to this.
minus 5.
Minus
5.
5q. Step 1, you differentiate. Step 2 equates to 0. What do we do? 0 is equal to what? 5,000 minus 5q. Step 3, we solve for q to find the output. So when this one comes this side, 5q is equal to 5,000. So what number of outputs will maximize total revenue? Q is equal to 1,000. All right. So when you put a 1,000 there, it will be 5,000 minus 2,500. So meaning our price will be what? 2,500. Then what is our total revenue? We just multiply these two, price times quantity, which is what? 2.5 million. So this is how we do revenue maximization. Okay. This is how we do revenue maximization. So how do we do profit maximization? Profit maximization is also another easy approach. We know that profit is equal to what? Total revenue minus total cost. You always put your total cost in brackets because of the nature of the total cost that you're usually given. All right. So total costs, we're told that total cost is a combination of the what? Fixed cost plus variable cost. Suppose your fixed cost is maybe 40 kwacha, and variable cost is 10 kwacha per unit. What becomes the total cost? It will be 40 plus 10 plus 10q. Okay. So this is our total cost function. And suppose we're given our total revenue as 100 minus the 100q minus, let me just say, given the price function as 100 minus 5q. So how do we find our total profit? Total revenue minus total cost. So from the price here, we need to calculate our total revenue. Total revenue is equal to price times quantity. So what is our price? 100 minus 5q. What is our quantity? Q. So just impose the Q there. So our total revenue therefore will be 100 Q minus 5Q squared. So now we use the entire formula here. Where there's total revenue, we're going to say 100 Q minus 5Q squared. And what is our total cost? 40 plus 10Q. So we put it in brackets here. So meaning what is our profit going to be? This will be 100Q minus 5Q squared minus 40, because the negative will make everything negative, minus 10Q. And you're going to rearrange them, the like terms and the unlike terms together. So this is 100Q minus 10Q minus 5Q squared minus 40. So what is the final profit? 100 minus 10 will be what? 100 minus 10 will be what? 90Q.
90Q.
And 5Q squared will remain alone. And 40 will just remain alone. So this is our profit function. So whenever you're asked to maximize, there are 3 steps. Number 1, you find that function. Number 2, you differentiate. I'm sure by now you know how to differentiate, all of you. If you haven't bought the videos for simple differentiation, please buy them. So number 2, differentiate. Number 3, you equate to 0. Equate to 0. Number 4, you solve for Q. And Q. So these are the main steps that you find when you're optimizing. So step 1, we found the profit function. Step 2, what do we do? We differentiate. So what is the derivative of the profit function here? So 90Q becomes what? 90. 5Q squared becomes what? 10Q. What happens to the 40? It drops because it's a constant. Step 3, what did we say? We equate to 0. So 0 is equal to 90 minus 10Q. Step 4, we solve for Q. When this one goes inside, we're going to have what? 10Q is equal to what? 90. So what is the value of Q? We divide both sides by 10. The value of Q will be what? 9. So what is the output that will maximize the profit? It is 9 units. Okay? Then what is the price? So here you said find what? Q and P. So we found our Q that maximizes profit. Then to find the price, you go back to the original price function in here. So what is the price that will maximize our profit? So where there is a Q, we're going to put 9. So 5Q. So here we're going to put 9. So 100 minus, what is 5 times 4? It's 45. Okay, so 100 minus 45, what do we get? 55. Correct. Then find the actual profit. So it's the same question here. Find the price and output that will maximize, that's 8 max. Then find the actual total profit. So the profit, you go back to the profit function. And in the profit function, you substitute the what? The quantity that you found. So in the profit function, we're simply going to say 90Q, where there's Q, you put what? 9. Minus what? 5Q squared, where there's Q, we put 9. Minus 40. Then you evaluate, you find the answer. So this is how we solve questions of such a nature. You need to follow those steps we've talked about. All right? So now let's answer this question in its context. So we're being given a question to say, suppose that the total fixed cost is 180 and the marginal cost per track is approximately 20,000. For a demand given by 30,000 minus 0.1, where P is the price, Q is the annual sales. So find the level of price and output that will maximize and find the annual profit generated. So what are we given in this question? Given the price, the marginal cost, and the fixed costs. All right? So we should also know that profit is maximized when total revenue, when marginal revenue is equal to marginal cost. That is another point we need to know. So let's tabulate the information given on Tata Motors. So given the information on Tata Motors, we're told that the price is 30,000 minus 0.1 Q. The marginal cost is 20,000 and the fixed cost is 180. So to maximize profit, we can say marginal revenue is equal to marginal cost. So how do you find the marginal revenue? I said the shortcut for this, we can just multiply a 2 there. So our marginal revenue will be what? 30,000 minus what? 30,000 minus what? 0.2Q. Remember this? or we can use the long cut. Price times quantity is your total revenue. So when you compute the price in there, you're going to have our 30,000 minus 0.1 Q squared. So to find our marginal revenue, we differentiate. So 30,000 differentiated will be 30,000. 0.1 Q squared, when differentiated, it will be 0.2 Q. So this is our marginal revenue. So since we're given the marginal cost, we want to find the price and quantity that will maximize profit. So we equate the marginal revenue to marginal costs directly. So our marginal revenue is this one, meaning our marginal cost has already been given as what? 20,000. So when this one goes inside, this one goes inside, we're going to have 30,000 minus what? 20,000 should be equal to what? 0.2 Q. Are we following? So 30,000 minus 20,000 is 10,000. So we divide both sides by 0.2. So meaning we divide by 0.2 here and 0.2 there. What do we get as our Q? 50,000. So we're going to have our Q as 50,000. So to find our price, we substitute here, we put our 50,000. So our price is equal to 30,000 minus what? 0.1, 50,000. So it will be 30,000 minus 5,000, which is 25,000. The price here will be 25,000. Are we following? Are we together?
Yes, yeah.
Okay. Any questions at this point? So how then do we find, what's the next part of the question asking us? The next part of the question is asking us to find what? The annual profit generated by the trucks. Annual profit generated by the trucks. So how do we find the annual profit generated by the trucks? We know that profit is got what? Total revenue minus total cost. Since we found our price as 25,000, so now total revenue is what? Price times quantity. So the price was 25,000, the quantity was 50,000. So we multiply that, we're going to get 1.2 billion. The variable cost was what? 20,000 Q. So where there's Q, you put 50,000, so we get what? 1 million. The total cost is variable cost plus fixed cost. So the variable cost we've calculated as 1 million. The fixed cost already given as 180 million. So when you add these two, we get 1.1 billion. So our total revenue is equal to, our total profit is total revenue minus total cost. So our total revenue was 1.2 billion. Our total cost was 1.18 billion. So the difference is 70 million. So this is how we find our profit for the year. So this is how we calculate that. Okay. So we can go to our next question, unless any questions on this one. Okay. So we go to the question to do with isocosts. What are isocosts? Isocosts are combinations that give us our lowest possible costs. Okay. So we need to look at the least cost combination. So from the definitions, who remembers what we said? What's the least um, cost combination? What did we define that? In our preamble, I'd explained what least cost is. Okay, so we've been given our combination. So maybe let me just take you through some concepts in isocosts. So what are isocosts? Isocosts are lines that join points that offer the same cost combination. So isocosts are simply lines that join points that offer the same what? Cost combination. If you're going to combine inputs like labor and capital, you are going to have the same cost amount. So those are called isocosts. So an isocost can be an input combination of two units. Um, in this case, we're going to look, say, x1 and x2. All right. So they look something like this, the isocosts. So they will give you with a formula: total cost is equal to the price of good one, okay, times quantity of good one, plus price of good two times quantity of good two. So this is a mathematical expression that we use where unit one can be labor, unit two can be what? Capital. So you can rearrange them into a straight line to calculate for each of the units. Say isocost would be given by the same optimal combination, that x2 is equal to cost over px2 minus price of good one over price of good two x1. So using a mathematical formula, we have an isocost line which shows this combination. And for this labor and for this capital. And the quantities, so using Q, we're using x1 and x2. So if you rearrange them, the formula of the straight line will be given by that. This is just similar to the straight line equation. Y is equal to what? Mx plus c. Just similar combination. So I just want you to understand step by step where we're going. Okay. Then if you want to calculate the intercepts, you can write the equation of the straight line to show you the intercepts as follows. So the intercept can be given by c over px, that is the intercept. The intercept is simply the cutting line. So an intercept is simply where it's cutting the y-axis. So this is the y-axis and this is the x-axis. So the cost over price of x, that is our intercept. So this is our intercept, c over px2. And the slope is simply the gradient, where you're going to divide the price of good one, px1, over the price of good two, px2. All right. So what is now the least cost combination input? It is one that produces a desired output at the lowest cost possible. So when we want to calculate the least cost combination, we need to factor out the following principles. Number one, we need to calculate our total cost of each combination. Number two, we need to compare the cost structures. And number three, you need to select the combination that will give you the lowest combination. Okay, so let's go to our two pricing structures that have been given in the question. So we've been given our pricing cases. Number one is PX1, which is 6.40, and PX2, 8 So meaning the total cost here will be 6.4x1 plus 8.0x2. The case 2, our price 1 was 0.75, our price 2 was 0.25. So the total cost here will be 0.75x1, 0.25x2. So these are the two cost combinations. Okay, so now we want to calculate which of these ones will give us our least costs in that context. Okay, how do we find? So we can come up with a table of combinations as follows to find the least cost scenario. So we have these combinations. You can assume values as follows. So when you input them in the equation, you're going to find one which gives you the lowest cost, what you pick. So in this case, we're going to combine for each of them, and you discover that